You're listening to the planet's memory, where time breathes and the Earth remembers. What if the Earth once burned in ways we no longer remember? What if the first heartbeat of our planet wasn't a sound, but a seething of light trapped in stone, a breath not of air but of fire swelling inside a world still being born? There were no oceans, no wind, no green, only the convulsions of heat, a pressure so immense that rock itself melted, rose, fell, and rose again, sculpting a crust too young to sleep. In those earliest days the Earth did not turn gently. It twisted, cracked, bled magma into its own sky. The atmosphere was a haze of steam and gas, thick with volcanic breath, pulsing with the slow exhalations of a planet not yet at rest. Above, the sun was faint, filtered through sulphurous clouds. Below, the Earth churned with inner fire, its core still forming, its mantle folding and unfolding like slow waves of molten memory. Land did not yet exist as we know it. There were only islands of hardened lava, drifting on a sea of magma, breaking, reforming, then sinking again into the red abyss. And in that chaos, silence was not the absence of sound, it was the absence of anything that could listen. But even then, something began to take shape. Zircons, tiny crystals, shimmering in the crucible of Earth's first fires, began to record time. They locked within themselves the memory of liquid rock cooling, of water condensing from the sky, of the planet's earliest whispers of stability. These were the first storytellers, not with language but with isotopic traces, locked into their lattice, temperatures remembered, pressures endured, the signature of an Earth beginning to hold itself together. And while nothing lived, everything moved. The crust thickened, buckled, shifted. Gravity folded the planet in on itself, creating fractures where lightless rivers of magma surged. With each eruption, each collapse, the surface of the Earth was rewritten, and yet every moment left behind a trace, a buried scar, a cooled ridge, a chemical change waiting to be unearthed. Perhaps this is the first dream the Earth ever had, to cool itself enough to remember, because memory, even in a planet, begins as heat, and heat, when it fades, leaves patterns. It leaves minerals. It leaves orientation in magnetic grains. It leaves ancient alignments in stone. These are the fossils of fire, the forgotten script of a world that had to burn before it could breathe. And even now, deep beneath our feet, the fires still burn. They shift continents. They lift mountains. They shape the places where oceans will rise and fall, and where we, one day, will walk and wonder. We are not separate from that fire. We were born of it, shaped by it, and warmed by its memory. The air we breathe, the iron in our blood, the minerals in our bones, all were forged in that crucible. It is not myth. It is not silence. It is history told in heat. And yet, if this much can be forgotten, what else might still be dreaming beneath us? From the furnace of the crust we rise into skies that once trembled with fire. Not the blue calm of today's atmosphere, but a shroud of ash and vapor, endless and glowing. The young sky was not silent. It flashed, cracked, and flickered with storms born of heat and metal. Each bolt of lighting wrote new chemistry into the clouds. Each eruption sent particles swirling upward. Sulfur, carbon, iron, dust from a planet still finding its voice. This was not weather, it was memory, forming in vapor. The air boiled with methane, ammonia, hydrogen sulfide, a noxious breath that made the sky glow orange and red. And through that haze, the Earth stitched itself together one breath at a time. Rain did not fall gently. It hissed. Raindrops collided with molten plains, turning instantly to steam, carving patterns into cooling basalt. These were not rivers, not yet, but channels of intention, hints of motion that would one day become flow, and from above, metals rained. Particles of iron and nickel born in the atmosphere or delivered by ancient impacts. settled across the surface like ash from a forgotten forge. They mixed with volcanic glass, merged with silicates, and cooled into strange compounds no longer seen on modern Earth. The crust became a canvas of alloyed memory, oxidized, fused, still warm from its own shaping. The sky was a partner in this creation, not passive but reactive, each storm a sculptor, each pressure shift a painter of planetary chemistry, and deep within those clouds, a quiet change had begun. Photons from the young sun danced with atmospheric molecules, breaking them apart, letting them reform. In those collisions, new pathways were drawn, complex carbon shapes, nitrogen fixings, molecules that over time would learn to reach for life. But life had not yet arrived. Only the ingredients, only the stage, slowly cooling under magma skies. And yet, the rock began to remember. In banded layers of ironstone, in the fine dust of volcanic ash, in trace elements trapped within crystal lattices, the earth was beginning to keep time, to record heat and pressure, to harden the rhythm of its own beginnings into permanent stone. It was still a violent dream, this world. Lava spilled without end. Mountains rose and crumbled in the same breath. But within the chaos, patterns were forming. Geology, like memory, does not begin in order. It begins in layers of fire and forgetting. And still the magma skies watched. They glowed through endless twilight, casting long shadows from jagged rock. They lit the steam as it rose, revealing the contours of continents not yet born. They shimmered with promise and dissolution, folding light into the earliest reflections of time. If we could walk there now, we would not recognize the earth, but it would recognize us in the iron of our blood, in the carbon of our breath, in the quiet fire of our cells, because the skies that once burned above the lava plains still echo in our bodies. We are not just descendants of life, we are children of weather, before weather, of storms that carved rock, of light that struck gas, of memory that began in heat. And yet, if the air itself once remembered, what else might still be stirring in the silence above us? Beneath that silence, the earth continued to dream, not in the skies this time, but in its own buried heart, a heart that never stopped burning. Down past the cooling crust, past the ragged scars of early tectonic drift, the mantle churned like a slow ocean of fire, viscous, dense, ancient. It moved not in waves but in pulses, like breath slowed by 1 billion years. This was no storm. This was memory in its deepest form, the memory of pressure, of heat held close, of energy unspent. Magma flowed through the earth like blood, unseen but vital. It rose in plumes, split apart plates, carved unseen canyons beneath the crust, and each movement, each convective turn shaped the outer world above. These were the cradles of ancient heat. They nurtured the early continents, lifting land from fire, holding it just long enough for rock to cool and fracture. They whispered to the surface without ever speaking, reshaping what would one day become the floor of oceans, the base of mountains, the ground beneath our quietest steps. And though we cannot see them directly, they remain beneath us, around us, rising and sinking like a dream. The earth has not yet finished. Geologists call them plumes, columns of slow-burning ascent, where mantle heat breaks through weakness, lifting the crust like soft skin. They create volcanic islands, basalt plateaus, hot spots that wander like old songs beneath the surface. But science can only name them. To feel them, we must listen differently. To the tremble beneath our feet when a distant fault shifts, to the rhythm of lava surfacing, not in chaos, but in cycles, to the magnetism of ancient flows, locked in orientation, telling us where the poles once pointed. This is how the earth keeps time, not in clocks but in cooled magma, in the chemical signatures of olivine, in the ratios of rare isotopes, decaying slowly into silence. And what's more, it remembers. Some of these magma rivers have been flowing for over 2 billion years, recycled, yes, but not erased. Their chemistry carries the fingerprint of Earth's childhood, the time when oxygen was rare and heat was identity. The crust above may shift, may weather, may vanish beneath subduction zones, but the mantle holds its secrets tightly, and from time to time, it shares them again in eruptions that unveil ancient minerals, in xenoliths, stony messengers carried upward from the deep, showing us rocks forged in darkness, pressures we cannot replicate, temperatures older than fossils. These are not just rocks, they are letters from the planet to itself. They speak of a time when life had not yet come, when the only movement was thermal, and the only witness was stone, and still the fire flows, slowly, quietly, purposefully, not to destroy, but to remind that the earth is never still, that below every calm forest and quiet street, a dream of molten movement continues, and perhaps that dream is what shaped us, because without those rivers of ancient heat, there would be no crust to break, no mountains to rise, no minerals to hold water, to hold life, to hold memory. All would be smooth, still, life. So we owe our chaos to the calm convulsions beneath, to the magma that pushed land above water, to the fire that gave the earth texture, to the cradle that never cooled entirely. And yet, if the earth still carries its childhood flame, what else might be glowing in the dark beneath us? From that warmth, something new began to stir, not fire, not vapor, but form, slow, deliberate, enduring. The crust, once a fragile skin stretched over the earth's fever, began to thicken. Broken plates of basalt, cooled from relentless lava flows, drifted on the restless mantle like rafts on a molten tide. They collided, split, rose, and sank, not with violence but with gravity's slow insistence. And in this silent shuffling the continents were born, not as we know them, not yet shaped into familiar outlines, not yet named by those who would one day walk their edges, but as raw masses of crust, jagged, volatile, alive with geologic hunger. Granite formed in the hearts of these fragments, thickening the crust, making it buoyant enough to resist being swallowed by the fire below. Where once only oceanic plates drifted, heavy and dark, now there were beginnings of land, lighter, older, destined to remain above the waves. These were the Earth's first attempts at permanence, at critonons, the ancient stable hearts of continents that would outlast mountain chains, ice ages, and extinction. They were not designed, they were sculpted by time, built layer upon layer through collisions, partial meltings, and slow metamorphosis, and still they moved, guided by mantle convection. The crust fractured into tectonic plates, floating on the asthenosphere, carried not by force but by flow. Each collision formed mountain roots, each rift opened seas, each subduction zone dragged the old into the furnace of renewal. This was the earth learning how to rebuild itself, and every time it did, something new remained. A sediment crushed into stone, a fault scar frozen in mid-thrust, a trace of magnetism aligned to a pole long since reversed. The continents wandered, they gathered, merged into supercontinents, then broke apart again. Pangaea, Rodinia, Nuna, names we give now to the restless dreams of drifting stone. But these movements were never random. They followed the heat, the weakness, the invisible rhythms of convection and cooling. They danced to the tempo of entropy, not chaotic but inevitable. And as they moved, the earth took shape. Shorelines formed where none had been. Volcanoes rose along subduction arcs, painting the sky with ash. Basins deepened into seas that would one day cradle life. And yet, the continents were not just land. They were libraries, holding within them the mineral memory of all they had endured, locked in the folds of metamorphic belts, in the age of zircons, in the isotopic decay of uranium to lead. Time itself became a signature, etched into granite and schist, preserved in the angles of thrust faults, held in the tilt of sedimentary beds folded long before eyes had evolved to see them. Even now, when we dig, we find these memories, and they are not myths. They are not stories told by chance. They are physical, measurable, repeatable, and yet profoundly mysterious. Because what is a continent if not a body of thought, a floating monument to the planet's instinct to rise above its own fire, a slow, grinding testament to change that forgets nothing? And so we walk on these cretins, on rocks older than bones, on scars that predate breath, on whispers from a world still becoming itself. Beneath every step, the plates continue to move, to press, to yield, to remember. And yet, if the ground beneath us was once molten silence, what else might it still be trying to say? Among the shifting plates and rising lands, some fragments did not forget. They did not erode. They did not melt. They did not drift far from where they first formed. But instead, they endured, zircons, tiny crystals, no larger than grains of sand, but older than oceans, older than air, older than the sky we now call blue. They are time made visible, not fossils of bone, but fossils of temperature, fossils of presence, of moments when the earth cooled enough to let something last. Each zircon holds within it a story of pressure, of water meeting fire, of elements locking into place like a planetary breath caught mid-exhale. To the eye they are nothing, fragments of crystal embedded in ancient rock, but under the lens of isotope science, they become lanterns from the Hadean Eon, a time we cannot see, cannot touch, but can still hear through the chemistry of uranium becoming lead, through the oxygen ratios whispering of rain, through the rare earth elements humming with clues about the early crust. In a single zircon we find the memory of a surface that had begun to cool, a crust solid enough to host rivers of liquid, brief moments of calm between the bombardments, maybe even lakes, maybe even the preconditions for life waiting in shadows we cannot yet define. And these zircons are not scattered. They are clustered in the oldest crystons in Australia, in Canada, in South Africa, buried in metamorphosed rocks that have folded and refolded for 4 billion years. We crush the rocks to powder just to find them. We isolate them with magnets, wash them in acid, mount them on slides like sacred text, and then we read them, not with eyes, but with instruments that measure time in the dance of neutrons and the decay of nuclei. What they tell us is not loud, it is not conclusive, but it is enough to know that Earth cooled earlier than we thought, that oceans may have existed before we believed they could, that the story of this planet's calm began not in the Archean, but long before, in the hidden interludes between catastrophe. Zircons are not storytellers, they are record keepers, and they do not lie. They carry silence the way glass holds light. They archive the planet's pauses, its inhalations between volcanic outbursts, its quiet before the rise of continents, its fleeting stability before the next upheaval. And they are still here, crushed into riverbeds, locked in granite veins, blown loose into dust that drifts across dry lake beds. When you walk the oldest ground, you walk over time itself. When the wind picks up and carries sand across your path, somewhere in that grainy whisper, a zircon may be moving, the same one that cooled when the earth was barely a thought. We do not need myths to feel wonder. We only need to hold a single zircon in the palm of our hand and realize we are touching the breath of a world that paused, cooled, and remembered. And yet, if something so small can survive 4 billion years, what else might still be hidden in the dust that surrounds us? The dust settled, the fire cooled, and then the sky began to fall. Not in pieces, not in fury, but in a long, unbroken rain. It fell for centuries, for millennia, soft at first, then endless, a weeping from the sky, as if the earth itself was exhaling the last of its fever. This was not the rain we know, not the fresh scent of spring, or the gentle rhythm of summer storms. This rain was acid, rich with carbon dioxide and sulfur, dripping through an atmosphere thick with volcanic breath. It struck the hot crust and turned instantly to steam, hissing like memory escaping stone, but the earth endured it, and the crust, once fractured and burning, began to drink. Lava fields turned to obsidian shores. Basalt plains grew slick with new rivers. Steam rose in curtains from every crack and fold, and clouds circled in denser swirls above the widening seas. This was the first meeting, the long-awaited kiss between fire and water, a touch that changed everything. The rain did not stop. It sculpted. It filled every basin, every fracture. It pooled in lowlands and sizzled on highlands. And slowly, steadily, it cooled the planet's skin, until at last it began to collect. The first oceans were born not in a moment, but in a surrender. Lava giving way to liquid, steam yielding to calm, chaos dissolving into depth, and with those oceans came silence. Not absence, but a deeper kind of stillness, the kind only vast water can create. Waves moved without witness. Currents circled the globe beneath an orange, clouded sky. Salt began to form, pulled from volcanic rock and carried into the tide. This salt, it wasn't added all at once. It grew slowly, like memory dissolving, iron by iron. The oceans became brine, and that brine, rich with sodium, chloride, calcium, iron, held the ingredients of futures not yet imagined. We often think of life beginning in water, but water itself began in fire, in comet ice and mantle vapor, in chemical reactions deep within Earth's crust, in the long condensation of atmosphere cooling, a billion small origins flowing together. By the time the oceans settled, they were mirrors to the sky, opaque, dark, turbulent. Yes, but beneath the surface they kept secrets the land could not hold. Minerals precipitated, sediment gathered, hydrothermal vents pulsed with warmth and chemistry, as if the planet's own breath was rising again through the sea floor. And above, the clouds thinned. Light began to filter through, soft diffuse, not yet blue, but no longer red with smoke. In this gentler world, the earth began to reflect, to listen to itself, to let water smooth the wounds of fire, to let tides shape the edges of stone, to begin slowly, to quiet. Even now, every wave is a continuation of that first touch. Every droplet of rain holds echoes of the storm that never stopped. The salt in our blood matches the salt first drawn from basaltic plains. When the crust cooled enough to keep, we are made from this meeting, from the first rainfall that turned to steam, from the vapor that thickened the sky, from the waters that formed not to destroy but to carry, and they still carry us. They hold the earth's deepest sediments, its buried heat, its sunken stories. So when you stand by the sea, know this: you are standing at the edge of the oldest conversation between fire and water, heat and hush, beginning and surrender. And yet, if silence began in the ocean's first breath, what else might still be waiting to rise from below, above that newborn sea? The sky still trembled, not with peace, but with possibility. Not yet blue, not yet ready for softness. It hovered in thick bands of haze and heat. The breath of the early earth was heavy. Ammonia swirled with methane. Carbon dioxide filled the air like a forgotten furnace. Hydrogen sulfide drifted from volcanic vents, carried upward in plumes that stained the clouds with sulphurous streaks. It was not air, not in the way we know it. It could not be breathed, not by lungs, not by birds, not by anything that dreamed of sky. And yet, it was not empty. It was alive with reaction. Ultraviolet light from the sun pierced through, unfiltered. It shattered molecules, split water vapor, cracked methane into radicals. In these invisible collisions, new combinations began to form, complex organics drifting as aerosols in the haze. The atmosphere, though toxic, was not dead. It was learning. Every shift in pressure, every solar flare, every volcanic eruption reshaped the composition, made it more layered, more dynamic, more capable of holding memory. And beneath those clouds, oceans stirred. not just with salt, but with dissolved gases, carrying atmosphere into water and water into air, a continuous breath, even without life to draw it. This was Earth's first inhale. A primitive, planetary respiration. Gases cycled between ocean and sky, between vent and current, between reaction and rest. What we call weather was not yet born, but already the seeds of movement had been planted, temperature gradients, pressure shifts, the beginnings of winds, of storms without names, of circulation on a scale too vast for sound. And through it all, the color of the sky remained hidden. It was orange, it was red, it was grey with photochemical smog. The blue we know was buried, waiting for oxygen, waiting for clarity. But that too was coming. Slowly, in the darkness of hydrothermal vents, in the shallows touched by lightning, in mineral pockets warmed by volcanic breath, something stirred, primitive metabolism, not yet life, but motion with direction, chemistry with rhythm, molecules clinging to structure, driven by entropy and guided by chance. The air played a role, feeding gases into ocean layers, where early compounds could bind, split, and bind again. This was the long breath before life, the inhalation before emergence. The atmosphere was not a barrier. It was a partner. It filtered, it shielded, it participated, and even now, trapped in ancient rocks, are pockets of that early air bubbles, sealed in zircon, traces in banded iron, ratios of nitrogen and noble gases that tell us what the sky once sounded like, because skies do have voices. They resonate in their chemistry. They hum in spectra, they shift in mood as their components change. And the early Earth, though harsh, was not cruel. It was learning how to hold breath, how to soften light, how to balance heat, how to prepare for something that might one day look up. That day had not come. But the air was practicing. Each swirl of methane, each lightning strike through ammonia clouds, each solar photon split across a water droplet, all part of the rehearsal for life's first song. So when we speak of sky, we are not speaking only of weather. We are speaking of history, of composition, of evolution without a name. The air above you now carries traces of that origin. Oxygen, yes, but also argon, xenon, neon, ghosts of the first breath still suspended in every exhale. And yet, if the sky itself once sang in toxic chords, what quiet harmonies might still be echoing in the spaces between clouds? Not all echoes drift upward. Some sink deeper into the body of the planet itself, where no light is touched, where pressure becomes language, and heat becomes memory. Beneath the continents and oceans, beneath the plates that drift like skin across a deeper pulse, the mantle flows. It does not rush. It does not ripple. It moves the way time moves, imperceptibly, but everywhere, relentless, circular, endless. Here in this silent interior, the Earth remembers what it was. The mantle still holds the original heat from accretion, the aftermath of collisions, the warmth left over from 1,000 impacts and a molten birth. This is the Earth's bloodstream, not made of water but of rock softened by pressure, not molten like the outer core but ductile, solid enough to resist, soft enough to move. In great convecting cells, the mantle rises and falls. Where it rises, crust thins. Where it falls, it drags ocean floor into fire. It is in this quiet churning that continents are guided, that rifts form, that mountain roots are born and buried. Nothing escapes the mantle's touch, not even silence. And still, it stores. It absorbs radioactive decay from uranium, thorium, potassium, an internal furnace, hidden and humming. This heat fuels plate tectonics. It builds volcanoes from nothing. It renews the surface by consuming it from below. We cannot see it, but we trace its breath in hot spots, in the curious alignment of islands, in the strange chemistry of erupted basalts that carry deep earth elements to the sky, and sometimes It offers up fragments, xenoliths, dark, foreign stones carried upward in lava from depths where diamonds form and pressure is enough to fold atoms into crystal. These stones are not intruders. They are pages from the planet's diary, torn loose by rising magma and cast ashore in eruption. They speak in olivine and garnet, in isotope ratios that betray their ancient origin, in chemical scars left by long ago melting events. And from these clues we reconstruct not just temperature and depth, but events, collisions of proto-continents, the birth and breakup of cratons, the very formation of the crust above. The mantle remembers what the surface forgets, where oceans erase, where winds wear down, where time buries, the mantle preserves. Its memory is not gentle, it is not delicate, it is dense, hot, compressed into silence over spans that exceed imagination. And yet, it is shaping us still. When a plate subducts, it melts into the mantle's dream, and in return the mantle gives rise to volcanoes, to arcs of islands, to the fertile soil of continents reborn. This is not destruction, it is recycling at the scale of worlds. The earth does not cling to its past, it consumes it, transforms it, and in doing so remembers everything. So when you stand on solid ground, know that you are held aloft by a sea of rock still in motion, that beneath your steps, beneath the roots of every mountain, a deeper rhythm moves unchanged since the beginning, and it moves not for us, but with us, because we are part of it, our continents, our minerals, even the carbon in our breath has passed through this unseen ocean of heat and pressure. We are shaped by what we cannot touch, and yet, if the mantle still carries the planet's first warmth, what else might be stirring in its slow and silent flow? From that depth, pressure rose, and where the crust was weakest, the earth exhaled. It rose not in words but in molten syllables, lava pushing skyward through fractures, seeking shape in a world still forming. From these outpourings came land, not continents, not yet, but islands, small, sharp, glowing red with youth. They emerged in oceans of stone, where basaltic plains cooled and cracked, where liquid rock met the early sea and hissed into shape. These were the Earth's first attempts at standing still, at staying above, at resting on the tide of fire that birthed them. Iron was everywhere, in the flows, in the cores of volcanoes, in the mineral blood of the rock itself. Iron carried heat, it carried weight, it darkened the crust, gave it strength, and helped the first roots of land hold firm. But the land did not last. These islands were not anchored, they rose, then fell, subducted, eroded, swallowed by the same heat that created them. Still some remained, fragments welded to cratons, basement rocks buried beneath younger layers, the skeletal beginnings of continents yet to come. Above them, the air shimmered with steam, the sea boiled at the edges, rain struck the glowing stone and rose again in clouds of mist, a cycle of touch and retreat as the earth learned to balance heat and water. Each eruption brought new land, each collapse made space for more. The surface changed constantly. It was not a stable planet, it was a restless one, painting and erasing its own skin over and over again. These islands were its brushstrokes. They told no story in words, but their shapes mattered, jagged, angular, layered in cooled lava and shattered obsidian. They broke the sea's surface like thought breaking silence, and in their shallow pools, minerals gathered, salts crystallized, tiny compounds drifted in from vents and tides, sticking to the porous rock like memory clinging to place. Even without life, the land began to host potential, iron and sulfur, silicates and carbon chains, the chemistry of becoming etched into the walls of basalt. We walk now on mountains built from these roots. They lie beneath every craton, every shield, every granite plateau. The continents remember, because the islands came first. They were the first scaffolding, the bones on which the flesh of forests and deserts would one day form. Without them, nothing would have stood. The sea would have owned everything, but iron changed that. It was iron that made the crust dense enough to hold, iron that carried the planet's magnetism, iron that drew down oxygen when it finally arrived, locking it into banded stones still found today. And as those early islands rose and fell, as they collided and fused, they gave rise to something new, land that could remain, not because it was stronger, but because it had been changed by fire again and again until it knew how to stay. Even now, in volcanic chains like Hawaii or Iceland, we watch the process repeat. Magma finds a path, builds land in the open sea, lets it cool, lets it grow. The earth still dreams of islands, and perhaps we are part of that dream. Because we build cities on volcanic plains, we trace the outlines of ancient island arcs in the rocks we mine. We live atop the forgotten bones of a world that once tried to rise and finally succeeded. We are the inheritors of those first glowing fragments. And yet, if land began as a struggle to stay above, what other memories might still lie submerged in oceans of stone, above those glowing islands and dark basalt plains? The skies churned without seasons. There was no spring, no winter, no rhythm of warmth and cold, only storms, ancient, unpatterned and vast. This was not weather as we know it. It was not born from jet streams or polar boundaries. It was born from imbalance, from fire meeting moisture, from pressure collapsing into chaos, from a planet learning to cool itself through fury. Lighting split the sky in jagged webs, drawn down to the iron-rich land like memory finding a mark. The air above crackled with charge, thick with static and ash, clouds swirling in towering convulsions that turned day to shadow. These proto-storms did not pass. They lingered. Eruptions fed them, methane fed them, ammonia, sulfur dioxide, volcanic soot, all lifted into the air in columns that collapsed under their own weight and fell as fire-laced rain. The earth had no seasons, but it had moods, and its earliest moods were violent. Each storm carved something, new valleys torn from young crust. Riverbeds formed not by water but by shock waves and sediment collapse, landslides without rain, floods without rivers, and in the aftermath, silence, a different kind of silence than before, not the molten hush of a lava world, but the damp quiet of ash settling, the soft breath of a world just rocked by its own cooling process. This was creation through erosion, a shaping force as old as gravity, because even then, even before climate, the earth responded to imbalance by smoothing itself, by collapsing steep ridges, by scattering mountains into plains, by letting wind and heat do what tectonics alone could not. The atmosphere had not yet cleared, but it had begun to listen. Each storm left behind traces, sediment layers in volcanic rock, oxidized surfaces touched by static discharge, tiny veins of metal fused into stone where lightning had struck. Some of these scars still exist, buried, compressed, locked within the oldest terrains, preserved in the chemistry of minerals that remember how heat and pressure once fell from above. And above all, the storms seeded change. Rain began to carry minerals from highlands to lowlands, smoothing edges, collecting compounds in pooling basins that darkened with richness. These would become the first cauldrons of complexity, shallow, warm, stirred by wind and charged from the sky, the very places where molecules learn to linger. We often speak of lightning as the spark of life, and perhaps it was, but before it gave life, it gave shape to land, to air, to silence. It was not random. It struck where charge demanded, where land was tall, where clouds grew thick, and as the crust cracked beneath those early storms, it opened new paths for steam, for lava, for chemistry. The earth was not yet stable, but it was becoming aware of its own limits, and so the storms became sculptors. They did not ask permission. They did not announce themselves, but they shaped everything. And then they passed, leaving valleys, leaving smoothness, leaving the soft, damp lull after the noise. Even now we feel their ghosts, in the shape of every canyon, in the pulse of thunder, in the way we instinctively watch the sky for signs of change. Because storms are not just weather, they are memory in motion. They are what happens when a planet feels too much at once and lets go. And yet, if the first silence came only after the storm, what deeper stillness might lie waiting beneath the noise we have yet to hear? Not every fossil is a skeleton. Not every story is written in bone, long before vertebrates, before shells and teeth, before spines curled into riverbeds and ammonites pressed their spirals into stone. The Earth began recording memory in a different way, through isotopes, ghosts of atoms, some stable, some ticking slowly into decay, each one a marker of what once was, a temperature, a breath, a change in light. These are the fossils without form, without limbs or eyes. They do not show a creature, but they show a world, oxygen isotopes, in zircon whisper of rainfall, and oceans, carbon isotopes, in ancient shale hint at metabolism without sunlight, sulfur signatures, in rock layers, speak of an atmosphere before oxygen took hold. They are not seen with the eye, but read with instruments, measured in ratios that shift by tiny margins, invisible but unmistakable. And in those margins, the Earth tells us what it once exhaled, what gases filled its sky, what warmth touched its waters, what pulses stirred its chemistry before life was anything more than a flicker in a mineral tide pool. The rocks breathe differently now, but they have not forgotten. In deep cores drilled from the oldest crust, in greenstone belts and banded iron, in the fine clay of ancient seabeds turned to slate, these isotope fossils remain. They do not crack or crumble. They do not fade with time, because they are time. A radioactive decay chain is not a relic. It is a countdown, a slow rhythm ticking towards silence. And even in that decay, there is story. Uranium becomes lead. Potassium becomes argon. Rubidium fades into strontium. Each transformation marks a boundary, a moment locked in crystal, a memory too dense to forget. The heat of formation, the cooling of magma, the water that altered feldspar to clay, all of it remains encoded in atomic shadows. These fossils are deeper than any vertebrate. They stretch back 4 billion years into the dark halls of Earth's first chemistry, and from them we learn not what lived, but what could have lived, what conditions held promise, what thresholds were crossed. We learn how air shifted, how continents formed and broke, how the planet itself changed character, not just in shape, but in breath. They tell us when the first oxygen appeared, and how long it lingered as trace gas before tipping the balance and changing everything. And they tell us something else, something quieter, that even in the absence of life, the Earth was always listening, always storing, always recording the way light fell, the way pressure moved, the way temperature danced across its molten skin. It did not need memory in the way we think of it, because it had minerals, because it had decay, because it had time. These fossils without bones require no eyes to see, no skulls to contain them. They simply are. They exist in every rock that tells time, in every crystal that formed under pressure, in every sediment that settled in a basin too quiet for fossils with faces. And in their quiet persistence they remind us that memory does not always look like us, that the planet has its own archive, one that does not erode, one that does not sleep. It just changes, atom by atom, until it is something else, and yet still remembers. So when you hold a piece of ancient granite or touch the face of a weathered mountain, know that you are holding more than weight. You are holding memory, time, called into silence, breath, trapped in stone, reactions that once danced through oceans we no longer see. And yet, if the Earth can still whisper through isotopes, What other stories might lie waiting in the silence beneath our fingertips? Where once there was only fire and stone, a softness began to settle, not in the sky, not in the seas, but in the smallest places where ash met water and silence met patience. From the aftermath of eruptions, fine volcanic dust rained down onto warm ancient seas, glass shards, minerals, fractured rock, all ground to silt by time and tide. They drifted gently, settling on the ocean floor in layers of ash that no longer burned. And in those layers, something changed. Water seeped between particles, heat from beneath warmed them. And slowly, over thousands of years, the transformation unfolded. Clay, not stone, not sand, but something else entirely. The substance born from fire, yet soft in its intention, layered, porous, alive with potential. Its surface so small and intricate, held spaces for molecules to rest, for elements to cling, for chance to repeat itself again and again, until repetition gave way to pattern. Clay became the Earth's first shelter, not for life, not yet, but for the ingredients of life, for amino acids formed in the presence of lightning and ultraviolet light, washed into warm pools, seeking places to hide, to gather, to begin. Clay held them close. Its structure offered charge, a quiet chemistry that attracted molecules, aligned them, nudged them toward bonds. It was not intelligent. It was not planned, but it was enough. Enough to become a stage, a substrate for what would one day replicate. This was not life, but it was rehearsal. It was memory in motion, learning how to fold itself into complexity. And the planet, still cooling, still shifting, let it happen. Rain fed the clay beds, tides stirred them. Hydrothermal vents breathed warmth from below, and in that rhythm, the improbable grew slightly more likely. Even now we find these clays, calalite, montmorillonite, smectite, in ancient shales and sediments, in the folds of greenstone belts, in the layers where organics began to appear. They do not speak, but they carry the shape of the world's first whispers, fine dry sheets that once were wet with potential. And beyond life, they continued to shape us. Clay held water, clay preserved fossils, clay hardened into slate, into mudstone, into the base of civilizations that would come and go without ever knowing how old their foundations truly were. Even now we press our hands into clay. We shape it, fire it, tell stories on its surface. But long before we did, it held stories of its own, unwritten, but not unkept. Because clay in its quiet way remembers. It remembers ash. It remembers tides. It remembers the electric hush of molecules gathering. And through it, we remember too, not in words but in structure, in the way our own cells fold, in the way proteins align, in the way life began with a stage too humble to see. So when you hold clay, when you walk across ancient shale, you are not just touching soil, you are touching transformation. You are holding what happens when fire and water agree to let something gentler emerge. And yet, if life found its first shelter in clay, what other impossibilities might still be waiting in the fine grains beneath us? Even before life stirred, before replication or instinct or breath, something else had already begun. A law, a pattern, a quiet unraveling, entropy, not chaos, not destruction, but the slow drift of energy from purpose to dispersal, from flame to ash, from alignment to spread. It began with the heat. The earth, once molten and fierce, was cooling. Each eruption lost more warmth than it kept. Each tide pulled by the moon slowed the planet's spin. Each new layer of crust stole energy from the fire below. Entropy was not an accident. It was a consequence. The price of existing, the pulse that followed every heartbeat of geology. In the crust it left patterns, fractures, called dikes, the fading thermal fingerprints of magma bodies now dark and silent. In the mantle, it showed as slower convection, less violent upwellings, a growing stability etched in isotope decay and seismic quiet. The early Earth was not dying. It was maturing, becoming more complex even as its heat unwound. Entropy is often misunderstood. It is not disorder for its own sake. It is the path all systems take as they explore every possible way to lose their energy. It is change, irreversible, patient, inevitable, and through entropy, the planet began to store more than heat. It stored contrast between hot and cold, between pressure and release, between form and dissolution. These contrasts became the engine for everything to come. Hydrothermal gradients in the ocean crust, atmospheric mixing above volcanic plains, minerals precipitating in cooling basins, leaving behind layers that told the temperature of their time. Entropy became a painter, its brush not chaotic, but mathematical. It traced lines in evaporites, shadows in metamorphic folds, deposits of iron and silica settling in rhythmic bands, as the Earth shifted from one equilibrium to another. And still, it moved forward. No moment could be undone, no warmth fully recovered, no crystal remelted in quite the same way. And so the crust, now thicker, now older, began to bear the signature of loss. And from that loss, life would find room to rise, because where entropy spreads energy thin, it also creates gradients, differences that can be used, edges that can be crossed, and life, when it did arrive, would thrive at those edges. It would feed on contrast, on imbalance, on the gentle slope between what was warm and what had cooled just enough to hold form. But before life came, entropy had already written the script. It had shaped the crust, thinned the atmosphere, slowed the Earth's rotation to a rhythm fit for tides. It had dimmed the noise so that the smallest signals could be heard, and though we cannot hold it, we see it still, in the decay of isotopes, in the cooling of the core, in the energy lost with every earthquake, every wave, every breath. Entropy is the shadow that follows every birth, and the guide that leads toward transformation. It is not the end, it is the slope we travel on the way to complexity, and the Earth, long before we arrived, was already following its path. So when we speak of order, of emergence, of evolution, we must also speak of this gentle decay, the first entropy, the first quiet fall toward balance. And yet, if even before life there was loss, what new forms might still be unfolding through the slow unraveling of time? From that long cooling hush, the Earth began to hum, not with sound but with motion, a slow tectonic rhythm that stirred beneath the crust like breath beneath sleep. The plates had already formed, born of crust and mantle. They drifted over the asthenosphere on currents driven by heat, by gravity, by the gentle entropy still unraveling below. They were not swift. They did not crash. They touched, glanced, slid past one another, their edges soft at first, then firm with repetition. And from these movements, the continents began to dance. They moved not like creatures, but like thoughts, slow, patient, returning always to the memory of their own drift. Sometimes they merged, embracing into supercontinents that rose like sleeping giants. Sometimes they pulled apart, stretching crust into ocean basins, opening new chapters beneath the sea. The Earth did not rush. It had time. It had breath. And in that breath it sang tectonic lullabies, songs written not in notes but in folds of stone, in orogenies that pressed mountain roots deep into the crust, in metamorphic belts that whispered of ancient heat, in the alignment of minerals that once felt the pressure of collision. Mountains rose where continents collided, not in violence, but in slow convergence, like waves pressing gently until the land folded upward to rest. And beneath those mountains, in zones of subduction and thrust, rocks were buried, compressed, recrystallized, their old forms softened into new identities. Slate from shale, gneiss from granite, marble from limestone, each a verse in the Earth's long lullaby, each shaped by time, by pressure, by silence, Some plates moved beneath others, slipping downward into the mantle's warmth, carrying the ocean floor with them, sediments, water, and all. There in the darkness they melted slowly, feeding the mantle and rising again as plumes of magma, a cycle of descent and renewal, like breath exhaled, then drawn once more. The continents, though made of rock, were never still. They swayed on the currents, tilted with the tides of inner heat, shifted their faces toward the sun and away again, changing the path of wind, of rain, of evolution itself. Even their collisions had cadence, rhythms of compression, followed by quiet phases of mountain building, followed by erosion, an inhale and exhale of geological time. We walk those rhythms now, on folded hills, on rift valleys, on the soft rises of land once buried, then lifted again by the memory of motion. We live on the edge of plates that continue to move, centimeter by centimeter, like clocks without numbers, marking time in friction, and beneath that friction, heat gathers. Earthquakes speak briefly of it. Volcanoes release its breath, but most of it remains deep quiet, stored in zones of contact, where rock touches rock, grinding slow poems into the crust. These poems are not lost. They are recorded in the alignment of crystals, in the tilt of fault planes, in the ages of detrital zircons that flowed from once high peaks. They tell us that the earth does not forget its movements. It rocks itself to sleep, and in doing so creates the very stage upon which life will evolve. Tectonics is not just motion, it is memory set in stone, a lullaby without sound, but not without shape. So when we feel the tremble of distant faults, or see the jagged edges of a rising range, we are watching the earth sway to the rhythm it has always known. And yet, if the crust itself hums with ancient lullabies, what dreams might still be unfolding in the folds beneath our feet? From the deepest mantle below the drifting plates, below the quiet convection cells, even beneath the roots of the tallest mountains, rose something older, something slower, something vast, superplume. Great columns of heated rock, thousands of kilometers wide, rising like breath from the base of the mantle to press against the crust above. They did not surge, they did not flash, they moved with such stillness that their presence could only be known by what came after. Flood basalts, continental rifts, mass extinctions, sudden shifts in ocean chemistry, events that seemed chaotic on the surface, had been rising in silence for millions of years. Superplumes are not eruptions, they are preparations, long risings of heat and pressure, gathering just beneath the lithosphere, until the crust at last gives way. And when it does, the earth opens. Basalt pours out in sheets hundreds of meters thick. Lava covers entire regions, forming traps, stepped plateaus that tell of ancient fire layered over time. The Deccan traps, the Siberian traps, they stand today as monuments to these deep invisible forces, to the slow breath of the planet that moves continents like leaves on boiling water. But these movements were not just local. Superplumes changed everything. They split apart land masses. They opened new oceans. They flooded the atmosphere with gases, carbon dioxide, sulfur, altering climate, reshaping ecosystems even before ecosystems could fully understand what was happening. In some eras, their breath was extinction. In others, it was renewal, because after the lava cooled, it left behind fertile land, mineral-rich, vast, ready for whatever life would emerge from the ashes of change. And though they seem catastrophic, superplumes are part of balance. They release the Earth's inner heat. They prevent stagnation in the mantle. They drive tectonics, reshape the carbon cycle, prepare the planet for the next chapter. We cannot see them directly, but we can trace their shape. In seismic tomography, we glimpse them as slow anomalies, heat held in vast towers beneath Africa, beneath the Pacific, still rising, still dreaming. And though their rise is too slow to witness, their signature is everywhere. in magnetic reversals frozen in rock, in sudden gaps in the fossil record, in the chemistry of ocean sediments that remember when fire met water and changed the balance of life. Even now we live in the shadow of these plumes. We build cities atop their remnants. We farm the cooled basalt that once surged like rivers. We study the rifts they opened and call them beginnings, not knowing how long the breath that caused them had been rising. The earth is slow, but it is not quiet. Its deepest motions are simply too vast for our clocks, too patient for our pace, too gentle, even in violence, to be called anything but inevitable. Superplumes are not anomalies. They are the exhalations of a planet, still learning how to let go. So when we walk across old lava plains, or stand at the rim of an ancient plateau, we are standing on the crest of a movement that began before species had names, a wave of heat rising from the vase of time itself. And yet, if even the planet's deepest breath takes millions of years to rise, what other silences might be waiting just beneath the crust for their moment to be heard? The earth has always known how to open itself, not with violence, but with pressure, gathered quietly, until the crust could no longer hold. And then, a slow parting, not a break but a yielding, like bread torn gently, revealing warmth and steam within. These were the first rifts, the zones where the crust thinned, stretched by the motion of underlying currents, and split apart to reveal the fire beneath. The fractures did not tear the planet in two. They offered and in that space the earth began to speak in a new language, one of movement, of exchange, of pathways born from separation. At the margins of continents, in the shadows of superplume uplifts, rifts opened, and into them flowed more than lava. Water seeped down, cooling the edges, carving channels into freshly exposed stone. Steam rose back through cracks, carrying dissolved minerals that crystallized as the temperature shifted, layer upon layer, vein upon vein, until the rock glittered with memory. Quartz, calcite, chalcopyrite, sulfur. Each fracture became a conduit for time, for chemistry, for whispers from the deep reaching toward the surface. These rift zones were not voids. They were beginning. They grew into mid-ocean ridges, continental basins, great faults where land pulled itself apart slowly, thoughtfully, as if making room for new stories. In the space created, life would one day find sanctuary. In the mineral-lined cracks, molecules would gather. In the geothermal warmth, cycles of reaction would begin. But even before that, before life, the rifts held purpose. They were reminders that the planet is not whole in the way we imagine. It is not sealed. It breathes through its wounds. And those wounds, though deep, are not disasters. They are invitations. They allow for movement, for pressure to release, for new crust to form from the mantle's breath. They shape oceans. They rearrange continents. They create the architecture upon which future ecosystems will rest. Even now we feel their pull, the great rift valley of East Africa, stretching slowly, breaking the continent open in silence, so deep it can only be measured in centuries. The mid-Atlantic ridge, a seam running down the center of the ocean, where magma rises like thought from the core, building new floor beneath the sea, and older rifts long since quiet, now filled with sediment, hidden beneath forests, still holding the mineral veins that once marked the breath of the earth. These places, though fractured, are whole in their own way, because fracture is not failure. It is adaptation. It is expansion. It is the letting in of water, of heat, of change. We often fear the crack, the break, the fault, but in the history of the planet, it is the fracture that opens the door to what comes next. So when we walk the edge of a canyon, or trace the scar of an ancient fault, we are standing in the very place where the earth allowed itself to transform, where it said yes to change, to connection, to depth. And yet, if every fracture carries both memory and possibility, what might still be flowing through the quiet cracks beneath our feet. Some memories do not rise from within. They fall without warning, without rhythm, but with force enough to rewrite stone. In the long stillness of Earth's early breath, the sky would sometimes break, not with weather, not with clouds, but with fire from beyond, meteoric impacts, the messengers of the cosmos, arriving not to speak, but to change. They came fast, metal and stone wrapped in ancient speed, striking the surface with a heat the planet had not yet learned to make for itself. With each collision, the air ignited. Shockwaves raced through ocean and crust. Rock melted instantly, vaporized, lifted into space before falling again as a rain of ash and shattered fragments. And in that ash, the Earth was marked. The craters they left were scars. Yes, but more than that, they were invitations to transformation, because the ash held more than heat. It carried rare elements: iridium, osmium, platinum, metals forged in the hearts of distant stars, delivered in brief flashes of destruction that seeded the Earth's crust with tools for complexity. Some of these impacts pierced deeply, driving material into the mantle itself, stirring convection patterns, disrupting plates, awakening volcanoes that might otherwise have slept for eons. Others struck the sea, boiling water into vapor, darkening the skies with soot, cooling the planet for years, then warming it again as carbon dioxide was released from fire-scorched forests and shocked stone. But long before forests, long before names, these collisions were part of the Earth's becoming. They brought entropy, yes, but also renewal, because change does not always arrive softly. Sometimes it arrives glowing, screaming through atmosphere, writing its name in pressure and heat. And the Earth, ever adaptable, received it. It folded the dust into sediment. It pressed the shocked quartz into the walls of basins. It cooled the melt into glass, creating layers that would one day reveal when and where the sky fell. Even now, we find these stories in tektites scattered across continents, in spherules buried in ancient seafloor, in isotope anomalies that tell of moments when everything changed because something arrived from elsewhere. We mark eras by these events, boundaries in stone where fossils vanish and new forms emerge, chapters of extinction and emergence, written in impact debris. And yet not every strike was catastrophe. Some brought water, some brought carbon, some may have delivered the very molecules that would later learn to replicate. We do not know which ones mattered most, but the Earth remembers all of them. Each ringed basin, each shocked mineral, each ash layer carried on ancient winds. They all tell us that chaos is part of the rhythm, that light and destruction are not always opposites, because from the violence came opportunity, from the impact came depth, from the dust came detail. So when we look to the sky, or hold a meteorite in our palm, we are not gazing outward, we are looking back, at a time when Earth was still being shaped, not just by what stirred within, but by what fell from without. And yet, if the sky once delivered both ruin and possibility, what other forgotten fires might still linger in the ash beneath our world? To know the Earth is to read its skin, not for color, not for softness, but for scars. They are everywhere, not wounds but records, traces of heat, of force, of passage, craters. Not only the fresh sharp bowls left by meteor strikes, but ancient buried hollows, subtle and softened, pressed deep into the crust where only gravity and magnetism reveal their shape. Some are shattered by time, eroded into invisibility, yet they remain, their outlines echoed in the stone that folded around them. Others are filled with sediment, with water, with forests that do not know the basin beneath them was once forged in seconds. These are planetary scars, marks of encounters with ice, with rock, with impact, with pressure, with internal breath. Not all scars come from above, some rise from within. Mid-ocean ridges split the seafloor open in long winding seams, raw edges where new crust is born. Subduction zones bend one plate beneath another, scraping, melting, reshaping crust into arcs of mountains and chains of islands. Rift valleys stretch the surface apart, leaving behind cliffs and basins where once contiguous land pulled itself into solitude. And all along fault lines the earth moves in bursts, grinds, slips, marks itself with folds and thrusts and offsets, signatures of tension that was held too long. We walk upon these stories, we build our cities in their shadows, we drink from rivers that carved through faulted stone, but often we forget what the land has endured. Each mountain range is not just uplift, it is memory, compressed and tilted. Each basin is not just lowland, it is the settling of broken crust, the silence after rupture. Even plains, seemingly flat and uneventful, may conceal the sunken remnants of collapsed volcanic domes, ancient flood basalts, or asteroid impacts buried in layers of sediment. The earth carries these marks without complaint. It does not conceal them, it simply allows them to become part of its shape. This is how a planet remembers, not by preventing damage, but by allowing it to be transformed. Heat becomes texture, fracture becomes form, disruption becomes design, and through it all, the mantle continues to rise, the crust continues to shift, and erosion gently edits the sharp edges into curves the eye can follow. Some scars are shared. Chicxulub, the mark of the strike that ended the age of reptiles and opened the age of mammals, still hides beneath the Yucatan, its circular form etched into gravity, its debris scattered across continents. Others are older, their cause is uncertain, like Vredefort in South Africa, the eroded remains of the largest confirmed impact on Earth, its central uplift now softened by 2 billion years of weather. These scars are not failures, they are history made visible. They are the stories the Earth could not tell in words, so it told them in stone, and we are born of them. Our minerals, our water, even our atmosphere, all shaped by the forces that left these marks. So when we run our fingers across folded rock, or trace the arc of a mountain range, we are not just touching land, we are tracing time. We are reading memory. We are feeling what it means for fire to cool into form, because every scar, no matter how deep, is proof of survival, proof of change endured. And yet, if every feature of the earth is shaped by memory and motion, what new forms might still be waiting to rise from beneath the patterns we think we understand? Not all transformation comes in fire. Not every rebellion begins with noise. Some begin in silence, in chemistry, in the quiet insistence of a single element that knows how to reshape the world without ever needing to shout. Carbon. It did not crash into the earth. It did not erupt. It arrived slowly, baked into meteorites, locked in minerals, rising in volcanic gases, dissolving in rain, settling into oceans, drifting into life. Long before lungs, before leaves, before language, carbon was already working, not with urgency, but with purpose. It bonded easily. It moved effortlessly. It built bridges between elements that had never touched until carbon brought them close. In the ocean it formed carbonates, shells that did not yet shelter life, but hinted at what might one day take shape. In the air it drifted as gas, a veil of carbon dioxide that held warmth against a cooling planet, long before organisms could regulate anything at all. And in the crust it infiltrated the very bones of the earth, transforming ultramafic rock into serpentine acidifying water to etch new minerals, altering mantle chemistry in ways that would echo for eons. This was not a violent takeover. It was a quiet rebellion, one that turned stone into sediment, because where carbon went, things began to soften, rain became more reactive. It wore down mountains faster. It dissolved minerals into ions and carried them to the sea. There, in shallows and basins, the ions reassembled, precipitating into limestone, building layers of carbonate rock that would someday rise as cliffs and reefs. With every cycle, more carbon was buried, more heat was retained, more complexity became possible. The planet was changing its own surface, its own air, its own rhythm, because of this one element moving quietly through everything. It slipped through boundaries, through solid and liquid, through living and non-living, through ocean and sky. Even now, it does not rest. Carbon cycles endlessly, through volcanoes and respiration, through weathering and photosynthesis, through fossils and fuels, through the breath of animals and the silence of coal. It holds memory in every form, in diamonds pressed into clarity beneath continents, in graphite, softly lining ancient metamorphic seams, in soot, settled in lake beds from fires long forgotten, in methane locked in permafrost, waiting. It speaks in ratios, carbon-12, carbon-13, carbon-14, each one a timestamp, a signature, a clue to origin. We use it now to date what once lived, to track where it breathed, how it moved, when it ended. But carbon's rebellion was never just about life. It changed geology first. It made the earth fertile before there were roots to grow. It seeded oceans with buffers, landscapes with chalk, mountain ranges with marble. And it continues. When we burn it, we borrow from its archive. We speak the heat of buried forests back into the air. We echo ancient climates in the warmth of our own time. Because carbon, even quiet, is persistent. It never stops finding new ways to connect. And so, when we look at a landscape, we are seeing its work, not just in forests but in cliffs, not just in lungs but in limestone, not just in life but in memory, a memory held not in words but in bonds, in how things are held together, in how they change without ever seeming to move. And yet, if one silent element could rewrite the earth, what else might still be quietly reshaping the world beneath our notice? Not all fossils speak of life. Some speak of structure, of system, of intention without mind. We often imagine technofossils as the legacy of our machines, glass, plastic, alloys preserved in the geological archive of the Anthropocene. But long before circuits, long before tools, the Earth had already begun to shape its own memory through matter. What if the first technofossils were not born of civilization, but of planetary instinct? Not machines, but minerals. Not tools, but crystalline sequences. Not by design, but by pressure, chemistry and time. There are places where metals align in strange formations. Not random, not living, but ordered. Vanadium layers in banded iron formations. Manganese nodules growing in silence across abyssal plains. Pyrite cubes forming with unnerving perfection deep in anoxic sediment. These are not alive, and yet they echo thought. Not human thought, but Earth's, its way of arranging, assembling, preserving reaction in structure. Technofossils of the deep past, in hydrothermal vents, minerals self-organized into chimney-like spires, layering sulfides, silicates, and rare elements into pillars that breathe with fluid heat. Inside these vents, microscopic chambers formed not by hand but by flow, spaces that confined molecules, guided reactions, replicated conditions that would one day support life. The planet was practicing, not towards a goal, but toward complexity. Even in basalt we find tiny tubes, iron-rich veins formed by water, percolating through volcanic rock, etching delicate hollows that mimic the branching of root systems or the filaments of nerves. Were they biology, or geology pretending to remember? Nature makes no distinction. Silica crystals grew in nested layers. Copper arranged itself in dendrites. Framboidal pyrite clustered like colonies. Patterns emerged, not alive, not aware, but undeniable. These mineral structures, stable through deep time, hold within them conditions that existed only briefly. Redox gradients, sulfur chemistry, thermal limits that no longer surface. They are more than deposits. They are archives, and like the remnants of cities buried beneath desert sands, they speak of systems that rose and fell without ever breathing. Technofossils, not of civilization, but of a planet learning to archive its own heat. What if these were prototypes, not of tools, but of possibility, of repetition? Bios, spatial memory, the idea that matter can remember how to organize, how to return to form, how to offer itself as scaffolding for the improbable. Perhaps every mineral vein is a kind of syntax, every geode a statement, every crystal a sentence the earth wrote to itself in the only language it had. Temperature, pressure, time, and even now, we build our technologies from the bones of these early systems. Silicon from quartz, conductors from copper, catalysts from platinum, batteries from lithium stored in brines that whisper of ancient waters trapped since the world was young. We carry these fossils forward, not in museums, but in our pockets, in our lights, in the circuitry of thought and memory. We did not invent order, we inherited it. So when we study the symmetry of crystal lattices, when we marvel at metallic bloom in volcanic glass, we are not witnessing accidents, we are seeing reflections of what the Earth knew before we arrived. And yet, if the planet could shape memory into metal, what else might it still be building in silence, deep beneath the crust, just waiting to be read? Not everything rises. Some things fall with grace, beneath the shifting plates, where the oceanic crust grows tired and dense. A quiet surrender begins. The edge of one plate dips beneath another, descending into the mantle, into darkness, into pressure, into a realm where stone flows like thought. This is subduction, the slow recycling of Earth's skin, not as destruction but as return. Old crust heavy with sediment, scarred with faults, etched with volcanic ash and fossils of vanished seas, is pulled downward. It bends, buckles, and finally slips into warmth. The Earth does not resist. It welcomes the descent, pressing the crust into deeper zones where temperature rises and minerals transform. Basalt becomes eclogoid. Water locked in oceanic sediments is released, rising like memory into the overriding plate above. And where that water moves, melting follows, magmas form, volcanoes awaken, and arcs of fire trace the surface above every trench. But deep below, a quieter transformation is unfolding. Whole landscapes, seafloors, ridges, island chains are being folded into the Earth's inner sleep, bent like lullabies, tucked beneath a dreaming world. Subduction is more than tectonics. It is the Earth's way of letting go, of pulling the past into its core, not to erase it, but to digest it, to reimagine it, to build something new from the old. Geologists study these zones with reverence. They measure seismic waves as they ripple through subducting slabs. They trace the arc of earthquakes and the chemistry of volcanic rocks to understand where and how memory mates. In some places, subducted slabs descend 700 kilometers or more, remaining intact far beneath the surface for millions of years. We see their echoes in the deep mantle's slow convection. We trace their path in anomalies of temperature, in the shape of continents curved by long-forgotten collisions. Sometimes the crust returns. Fragments of ocean floor are thrust upward, preserved in mountain ranges, forming ophiolites, pieces of the deep lifted into light. They tell of vanished oceans, of trenches now erased, of plates that once moved in opposite directions and now lie still in stone. These rock sequences carry whispers of pressure once endured, of minerals reformed, of heat passed through like dreams through sleep, because the Earth does not forget. Even what sinks is not lost. It is metabolized, incorporated, rewritten. Subduction zones shape the continents themselves. They build crust through volcanic arcs. They thicken land through collisions. They recycle oceanic plates so that nothing stagnates, so that every rock has a chance to become something else. Even we, our cities, our mountains, our quiet walks through ancient valleys, exist because of subduction's long dream. It created the Andes, the Himalayas, the Japanese archipelago. It built the ring of fire that still breathes ash and magma into the air as the world shifts beneath us. And one day, even our land will slide into those trenches. Not today, not soon, but inevitably. Everything is moving, everything is returning, and that return is not an end. It is rest, it is renewal, it is the folding of landscapes into the dark warmth where minerals change and memory softens into the raw material of new futures. So when you stand by a mountain lake or trace the curve of a coastline, remember, it was once deep sea, it may be sea again. It is all part of the same motion. Subduction is the planet's exhale, its sigh, its sleep. And yet, if even the continents are dreaming of descent, what memories might they carry with them into the quiet heart of the earth? High above the trenches, above the subducting crust and rising magma, another transformation had begun, not of rock, but of air. And it began, not with thunder, but with light, not the oxygen we breathe today, but a hesitation, an offering that arrived slowly, uncertain, unnoticed by the planet, for nearly 1 billion years. It began with cyanobacteria, tiny architects of unseen futures, drifting through shallow seas where sunlight filtered into warmth. They needed little water, carbon dioxide, light, and from those they built their own form, their own memory, and as a byproduct, they exhaled oxygen, not for purpose, not for us, but because chemistry allowed it, because electrons moved and molecules rearranged, and the ocean began to shimmer with something new. At first the earth did not accept it. The oxygen was seized by iron, by sulfur, by volcanic gases hungry for reaction. It was locked into banded iron formations, rusting entire oceans into red slumber. It oxidized the crust. It vanished into stone. It disappeared into sediment like a secret unshared. For millions of years, it built up only to be hidden again, given then buried, exhaled, then silenced. This was the oxygen hesitation. The planet paused. It resisted breath. It clung to an atmosphere of methane and carbon dioxide, to the familiar warmth of greenhouse haze, and all the while the cyanobacteria continued, unbothered, unseen. Layer upon layer of microbial mats grew across tidal flats. Stromatolites rose like ancient lungs, slowly sculpting mounds of calcium and life. They recorded tides. They shaped chemistry. They wrote time into stone, not with words but with layering. Still the air remained silent, still the skies held no blue. But eventually, the balance tipped, the sinks filled, the oceans rusted out, the rocks grew saturated with memory, and oxygen began to rise, not just in sea but in sky. It did not arrive as salvation, it arrived as disruption. The great oxidation event was not a gentle transition. It was extinction for those organisms adapted to anoxic worlds. Oxygen was poison, but in that poison a door opened, a path toward complexity, toward breath. With oxygen came new reactions, new metabolism, new ways to store energy and move it with elegance. Cells became more than chemistry, they became potential. The sky changed. Clouds formed with new softness, light scattered differently. The world began to glow. The air became breathable, not yet for creatures, but for the idea of them. This was the end of one age, the age of fire without limit, of methane haze, of sulfur winds, and the beginning of another, an atmosphere that could remember, that could cradle warmth with restraint, that could reflect light with nuance, that could support something fragile. And still, oxygen was not finished. It would fall again. It would rise. It would dip and climb through epochs and ice ages, through blooms and extinctions, always tied to the pulse of life and stone. Even now, its presence is a balance. We breathe it, but we do not command it. It is the breath of the earth, shaped not by will, but by billions of years of microbial labor and planetary patience. So when you inhale, remember, You are drawing in a gift that almost never came, a gift that was offered again and again, until at last, the world said yes. And yet, if oxygen waited so long to speak, what other elements might still be gathering the courage to change the world again? The earth was already awake, breathing, drifting, growing crust, exhaling gases and gathering clouds. But the sky had not yet opened its eyes. For so long, it had worn a veil, a shroud of haze and ash, carbon-rich, sulfur-laced, thick with photochemical murk from volcanic breath and methane dreams. The light that touched it was scattered poorly, blocked, refracted, tinted by particles that turned the air golden brown, red and dim. There was no blue, not because colour did not exist, but because the world had not yet cleared enough space for light to play, and so the sky waited, not silently, but patiently, until the oxygen came, slowly, as hesitation, as whisper, as promise, and with it came change. As oxygen accumulated, methane fell, sulfur retreated into rock, particles dropped out of the sky and settled into the sea. The air began to clear. Bit by bit, light began to pass through in finer gradients. Shorter wavelengths were no longer lost to smog, but allowed to scatter, and so for the first time the sky turned blue, not all at once, not with fanfare, but with a gradual shift, like the way dusk folds into night. The blue was not just colour, it was evidence of transformation, of breath, of balance. To see a blue sky is to witness the scattering of sunlight by molecules small enough to catch it gently. Oxygen, nitrogen, dancing with photons in the upper air. That blue is not painted, it is performed again and again. Every day the planet allows light to pass. But this first blue, this earliest opening, was more than scattering. It was a mirror, a reflection of all that had changed within the earth, and above it, the oceans reflected it back. Not perfectly, but enough to echo what the sky had finally learned to hold. For the first time, the planet looked like itself. Not just rock and water, but atmosphere, a veiled breath so finely tuned that it could cradle light and soften the harshness of day. We take it for granted now. This blueness overhead, we speak of it in metaphors, in dreams, in distance. But once it was a miracle, a threshold crossed, proof that the atmosphere had cleared, that oxygen had risen, that fire had paused long enough for softness to appear. In ancient rocks, we find traces of this shift, a disappearance of sulfur isotopes, a drop in methane-rich sediments. The first red beds formed in the presence of free oxygen that rusted iron in place. And with the sky's blue, the world grew quieter. The greenhouse haze diminished. Temperatures stabilized. The light became gentler. Life, still microscopic, now basked beneath a color that signaled clarity. Photosynthetic organisms expanded, reaching deeper into oceans, pushing oxygen higher still, making the blue deeper, truer, steadier. It became a feedback loop, a lullaby of color and chemistry that would sing the world into a new kind of balance. And though the blue would darken in ice ages, vanish behind volcanic ash, retreat in times of carbon bloom, it always returned, because it is more than color. It is the signature of a world that has learned to breathe and to scatter light gently as a promise. So when we gaze upward now, from forests or oceans, deserts or cities, we are looking into memory, a memory of transformation, of the moment Earth revealed its true sky for the first time. And yet, if the sky had to clear itself before it could shine, what hidden hues might still lie beyond the blue, waiting for their time to return? Even beneath that open sky, beneath the waves, the soil, the shifting plates, there are voices that never fade. They do not speak in words, they do not rust or crack or wear. They are steady, patient, and precise. They are isotopes, the quiet storytellers of time, locked within crystals, trapped in layers of ice, embedded in shells, frozen in lava. They are the planet's most reliable memory, Because while rocks may erode, while valleys may fill, and continents drift, the ratio of isotopes remains a balance of atoms, a tale told by mass and decay. They whisper of temperatures once felt, of climates warmed and cooled, of atmospheres rich with carbon, or thin with the breath of oxygen's first ascent. Oxygen isotopes in coral and foraminifera tell of ancient seas, their warmth, their salinity, their cycles of rise and retreat. Carbon isotopes speak of life and death, of photosynthesis gained and forests lost, of pulses in the deep carbon cycle that align with the bones of extinction and bloom. Lead tells the age of zircon. Argon holds the cooling of volcanic rock. Uranium's long decay charts the age of Earth itself, not in mystery, but in certainty. Each isotope is a timepiece, a relic of origin and passage, a ticking silent pulse through minerals and magma, through ice cores and sediments, through bones and breath. They are not altered by wind, they do not fade with light. They hold no opinion, no bias, only ratio, only rhythm. And in that rhythm they archive the deep past with astonishing grace. Isotopes. Remember what the surface forgets, where rivers cut through stone, where glaciers scrape valleys clean, where forests turn to soil and are reborn. Isotopes endure. They are buried beneath change, but not erased by it. They tell us how the earth has spun, how the sun has shone, how volcanoes have spoken, how oceans have breathed. And when we listen, when we extract, analyze, compare, we are not guessing, we are reading the isotope library of a planet that has always kept its receipts. In layers of ice, in Antarctica, isotopes of hydrogen and oxygen record each snowfall, each season, each shift in atmospheric circulation stretching back hundreds of thousands of years. In stalactites hidden deep within caves, isotopes tell of rainfall and drought, monsoons long faded, climates reborn. In the enamel of ancient teeth, in the shells of trilobites, in the feathers of fossil birds, they mark migration, diet, origin. Isotopes do not sleep. They do not soften. They are the unblinking witnesses to Earth's long transformation. Their language is mathematical, but their voice is poetic. A chorus of tiny masses, each one just different enough to reveal what has passed, and how fast it passed through. Even today we measure ourselves through them. The carbon-14 in our bones ties us to the atmosphere. The isotopes in the water we drink can reveal the path it took from glacier to glass. We are not separate from these storytellers. We carry them in every cell, in every breath, in every memory passed from planet to person. So when we speak of Earth's memory, we must not only think of fossils, of stones, of landscapes. We must listen deeper, to the atoms that remember, to the ratios that endure, to the isotopes that never stopped telling the truth. And yet, if the Earth has always spoken in ratios, what secrets might still be sleeping in elements we've yet to hear? There were times when the world grew quiet again, not with peace, but with cold. Ice returned, not briefly, not seasonally, but across epochs. It spread from the poles, sweeping over continents, burying valleys, sealing seas in silence. These were the glaciated eras, deep freezes where snow fell not in storms but in generations. Whole regions disappeared beneath kilometers of white. Mountains wore caps of frozen breath. Rivers turned to stone, and the sky grew pale with reflection. It would be easy to think the planet had gone still, that the inner fire had dimmed, that entropy had won. But beneath the vast silence, the earth still glowed. Beneath the grinding ice sheets, the mantle breathed. Tectonic plates drifted onward, undaunted by the weight of glaciers. Rifts opened in silence. Subduction carried old crust into the heat of memory, and in the hidden places, lava flowed. In Iceland, in Antarctica, in the depths of the mid-Atlantic ridge, volcanoes erupted beneath the weight of frozen ages. Subglacial eruptions, left behind ghostly formations, flat-topped mountains called tuyeres, formed where magma met ice and quenched in place, basalt pillow, lavas piled beneath the meltwater lakes that pooled under glaciers, too thick to notice the fire below. Even in full snowball Earth conditions, when ice stretched near the equator and the planet's skin glittered white, the core stayed molten, the mantle still rose, hydrothermal vents still pulsed in ocean basins, feeding life that needed no sunlight. The Earth never stopped, it simply shifted its rhythm. Fire beneath the ice was not contradiction, it was balance. A reminder that beneath every stillness there is motion, that beneath every hush there is breath, and that fire, though quiet, remembers. In glacial sediments we find layers of ash, thin bands of volcanic memory pressed between years of snowfall. In ice cores we trace sulfur spikes, signatures of distant eruptions that painted the skies grey even as snow continued to fall. In geothermal vents beneath Antarctic shelves, warmth still carves channels through frozen foundations, allowing creatures to gather, to linger, to dream in the dark. This was not a world asleep, it was a world retreating, reflecting, making space for something new, because ice is not erasure, it is preservation, and fire is not destruction, it is continuation. Together they wrote the Earth's deep cycles, glacial advances and retreats, volcanic stutters and flows, long rhythms that stretch beyond history, beyond memory. We carry the marks of both, in the fjords shaped by glaciers, in the ridges formed by lava, in the soils enriched by ash, in the freshwater carved by melt and magma, meeting in secret. Even now, beneath Greenland and Antarctica, heat continues to rise. Volcanic provinces lie hidden. Geothermal pulses warm the base of the ice, lubricating its motion, whispering to the future that nothing frozen lasts forever. The Earth turns, and the balance shifts. Ice melts, fire flows, and from their conversation new worlds are born. So when we walk upon snow, or peer into frozen lakes, or trace the boundaries of retreating glaciers, know that fire has always been near, watching, waiting, warming, without noise. And yet, if fire can glow unseen beneath the deepest cold, what other forces might be shaping the world from within shadows? We cannot yet feel. The Earth, in all its seeming permanence, has never kept anything forever. Not mountains, not oceans, not even its own skin. Everything returns, everything is reused. The rocks that once formed towering peaks now drift as dust across deserts. Cliffs that held the weight of glaciers crumble into sediment, pulled by rain, by wind, by time. What was once granite becomes sand. What was once volcanic ash becomes clay, pressed into shale, layered into the quiet of seafloors that gather memory grain by grain. The Earth is not a keeper of form, it is a recycler of memory, a long, slow artist that takes yesterday's monument and makes from it a foundation, a floodplain, a fossil bed, a beach. Nothing here is lost, only rearranged. A sandstone ridge in a desert may have once stood as part of a mountain chain crushed in a tectonic collision millions of years ago, its minerals weathered from height to powder, carried by rivers to deltas, pressed and hardened again into something new. This cycle is not short, it is not loud, it is the breath of a planet inhaling structure and exhaling transformation. Even the ocean floor is not immune. Every few 100 million years it is swallowed at subduction zones, dragged into the mantle, melted, mineralized, then reborn at spreading ridges as new crust. The seafloor you see today will be gone someday, not erased but consumed and remembered in molten form, to rise again in another time. And yet the memory remains. Isotopes endure the cycle. Trace elements speak of origins, even when structure has changed. A grain of quartz in a river might still carry the signature of pressure felt when it lay deep within a mountain root. A zircon crystal found in beach sand might be older than the continent it sits upon. These fragments carry time like pollen carries possibility, drifting, settling, waiting to root again. Even life plays its part. Shells become limestone, forests become coal. Creatures fall into silt and rise again as stone. The carbon in our bones may have once passed through leaves in a forest long turned to rock. The iron in our blood was once forged in a star captured by earth, cycled through magma and crust before finding form in us. We are like the land, recycled. This planet does not create endlessly from nothing. It shapes from what it has known. Metamorphic belts twist old rock into new forms. Like folded pages in a book, rebound. Faults grind ancient sediments into gouge, ready to be lifted as new peaks. Volcanoes build land from the melted bones of long-forgotten seafloors, and in each layer, a memory survives. Not whole, not pure, but enough to tell us this has happened before. That time moves in circles carved from stone. Even the air reflects this pattern. Carbon exhaled by ancient volcanoes returns now through the breath of mammals, through the burning of forests, through the slow decomposition of all that once lived. The earth in its wisdom recycles not just material but experience. And so when we walk through a canyon or pick up a pebble from a trail, we are holding the ghost of a world that has risen and fallen more times than we can count. We do not live atop the first crust. We do not breathe the first air. We do not drink the first water, but we hold all of it in new forms, in changing shapes, in recycled worlds folded into our own. And yet, if every mountain crumbles into sand, what ancient fragments might still be waiting beneath our feet, ready to rise again? Before the rain was gentle, before it brought life, it came as an alchemist. The first rains fell under a sky choked with volcanic breath, an atmosphere thick with carbon dioxide, sulfur dioxide, ammonia, and methane. The clouds that gathered were dense with chemistry, formed not from cool oceans but from the condensation of gases exhaled by a restless earth. And when that rain fell, it was not sweet. It was sharp, acidic, heavy with dissolved minerals, rich in carbonic and sulfuric solutions that fell upon a crust still hot with youth. It sizzled on basalt. It hissed through ash. It met fresh lava flows and turned instantly to steam, etching trails across newborn land like handwriting in smoke. This rain tasted of stone. It drank from the air's mineral breath and gave it back to the land. And in doing so, it carved the first rivers, not wide, not deep, but persistent. 1,000 rivulets cut through brittle volcanic plains. They widened over centuries, over millennia. They joined together. They deepened. They whispered down slopes, gathered in basins, pooled into the planet's early lakes and seas. This was the beginning of erosion, not as destruction but as storytelling. Because rain remembers every surface it touches, it holds the memory of mountains. Even after they've washed to the sea, it carries the trace of each grain, each iron, each soft sediment it rolls forward. And through its endless motion, the land was shaped. Canyons began not with force, but with repetition. Floodplains formed not by chance, but by pattern. Valleys opened because rain continued to arrive with purpose. No creature yet imagined. Even now, the chemical signatures of those rains remain. We find them in paleosols, ancient soils preserved in rock, marked by leaching patterns and iron oxidation that reveal how acids moved through the crust. We find them in the ratios of strontium and neodymium in sediment layers, telling us what kind of rock was once dissolved and carried away. We see it in the siltstone, in the mud cracks preserved like wrinkled skin, where ancient lakes once breathed under a foreign sky. And all of it began with rain, water pulled from the early atmosphere, infused with fire's chemistry, and sent back to sculpt the world from the top down. This was the Earth's slow surrender to smoothness, and yet, even as it softened cliffs, carved watersheds, and fed the seas, It was preparing something more. The weathering of rock by acid rain released not only minerals, but nutrients, phosphorus, calcium, iron, the building blocks of life set loose from crystal form. In the runoff, these elements mixed with carbon. They entered oceans. They balanced the pH of early seas. They laid the chemical groundwork for metabolism, for shells, for skeletons that would not appear for eons. So rain, though empty of life, was already writing life's preamble. It eroded, but it also built. It stripped, but it also seeded, and today it still carries memory. Every drop of water has touched stone, has fallen through sky, has worn away something once sharp, has given shape to something we now call home. So when you stand in the rain, when you hear it whisper against windows or leaves, know that you are hearing the voice of ancient water, reborn from clouds that remember a world where rock met acid and softened into story. And yet, if rain could shape the land before life began, what new landscapes might it still be dreaming into form, from the wash of minerals left behind by ancient rains, from the cooling of volcanic melt, from the quiet chemistry of time? A crystal began to take form, not loud, not bright, but constant, unfolding atom by atom in silence. Silicon and oxygen, the two most abundant elements in the Earth's crust, bonded again and again into a repeating lattice, a structure so precise it could trap light and hold it still. Quartz, born not from chaos, but from calm after fire. It formed in pockets of granite, in the slow cooling of magma chambers, in fractures filled with hydrothermal flow. It grew in voids left behind by gas, in crevices opened by tectonic motion, in veins that marked the paths of ancient waters, and there it hardened, a crystal that held no color except what the world offered it: clear, milky, rose, smoky, each hue a whisper of trace elements, of radioactivity, of pressure and time. Quartz is not rare, but it is remarkable. It does not erode easily. It resists chemical weathering. It outlasts the rocks it once grew within. And when those rocks break, quartz remains. It rolls into rivers. It gathers on beaches. It forms the backbone of sand. The glimmer in dunes, the sparkle in deserts. We walk on the dust of quartz. We build with it. We shape it into glass, into timepieces, into prisms that divide sunlight into spectrum. It reflects, but it also remembers, in inclusions. It traps ancient fluids, tiny pockets of seawater or hydrothermal brine sealed for millions of years. In growth rings, it records changes in chemistry, like tree rings born of stone, and in its clarity, we see the ghost of fire, because quartz forms only when the heat subsides, only when magma slows, only when pressure allows order to emerge from melt. It is a mirror not just of appearance, but of process, a frozen thought of what the Earth once endured. Even now, it grows. In hot springs, silica-rich water deposits quartz layer by layer around sinter terraces and geysers. In fractures deep below, veins still form, carrying with them gold, silver, and other metals that cling to quartz as if drawn to memory. In our technology, we still turn to quartz for precision. Its internal rhythm, its piezoelectric response, allows it to vibrate with astonishing regularity when charged. We use it to keep time, to stabilize circuits, to tune the invisible frequencies on which our voices travel. Quartz formed from ancient heat now orders our modern world, and yet it remains humble, still found in gravel, still scattered on riverbanks, still forming in silence. It is the Earth's slow mirror. It reflects not faces but processes, not moments but eras. So when you find a shard of quartz, when you hold it to the light, you are not just seeing reflection, you are seeing a story of cooling, of balance, of pressure resolved into clarity. It has been underground, it has been shattered, it has been melted and reborn, and still it holds its shape, because some memories are meant to endure. And yet, if quartz can still reflect the calm after fire, what other crystals might lie hidden in the crust, remembering moments we've never known, There are fires we never see. Fires that don't rise in flame or light. Fires that leave no smoke, no glow, no warning. But they burn, silently, steadily, beneath our feet, and sometimes within us. Because not all fire is combustion, some is transition, some is energy caught between states, between heat and thought, between field and form. In the deep earth, mantle plumes still rise, undetected by eye, but traceable in anomalies, shadows in seismic waves, ripples in gravity, whispers in the way continents shift. They are slow, too slow for sensation, too quiet for sound, but they are real. In the crust, magnetism tells another story, not of burning, but of charge, of iron atoms aligning with the Earth's field as molten rock cools. A frozen compass that points to past pole reversals, to tectonic drift, to hidden igneous roots beneath planes we thought were simple. This magnetism is a fire in form, the movement of electrons, the residue of planetary heat translated into field. It touches everything. Birds feel it, rocks record it, satellites measure its pulse as the magnetic poles wander and sometimes flip entirely. Even our own technology has begun to detect fires we did not know how to name. Deep in data we now see thermal signatures, where no surface heat exists, hydrothermal circulation, under ice, radiogenic decay, deep in the crust, frictional heat along slow-slipping faults that store strain like a held breath. These are embers, fires of a different kind. They do not blaze, they wait, and still, we walk across them. We live above forgotten calderas, we build on ancient rift zones, we dream on land that has only recently cooled, and perhaps some fires burn even deeper, not in rock but in potential. The fire of instability, the fire of change, the fire of unknown physics, locked inside matter we do not yet understand. Neutrino fluxes, gravitational murmurs, energy fields that pulse through space and touch the earth in ways we have not yet learned to feel. These fires may be the oldest of all ignited, not by planets but by the birth of the universe itself, and yet they burn within us, in the decay of potassium in our cells, in the radiation that forms and fades within our very bones. We are, in a sense, walking embers, fragments of energy held just long enough to wonder where we came from. The earth, too, holds this fire. In every place that seems still, there is motion. In every place that feels cool, there is warmth below. In every record we cannot explain, there may be heat not yet named. So we study, we measure, we listen, we drop sensors into the ocean, we launch satellites into orbit, we mine data the way we once mined gold, searching not for wealth but for patterns. And the patterns whisper, the fire never left. It simply changed its language. Now it speaks in isotopes, in anomalies, in subtle gradients and shifting fields. Now it burns not in forests but in frequencies, and still, it shapes the world. So when we look across a calm field, or sleep beneath a silent mountain, we are not far from heat, not far from energy. We are held always by the fire we cannot see, and yet, if the earth still carries invisible embers, what final sparks might be waiting to reveal the last memory beneath our feet? Beneath every silence, something remains. The planet moves slowly, but it forgets nothing, not the ash that fell from skies, lit by impact, not the folded layers of ancient seas, not the whisper of oxygen rising through a new blue sky. All of it, every moment is kept, archived in crust, in crystal, in cold, in fire. Earth has no memory like ours. It does not recall in pictures or words. It recalls in form, in chemistry, in depth. A landslide writes itself into layers. A flood etches its path into deltas. A volcanic eruption becomes a chapter of ash spread across continents. A timestamp, a punctuation mark in the book of time. Even storms leave memory. in tree rings, in ice cores, in the oxygen ratios of layered sediments that settle softly year after year into the bottom of a lake that has never been drained. Each piece is small, but together they form a memory far deeper than any single moment can hold. The planet remembers through repetition, through motion, through burial, through transformation. Nothing is truly erased. The continents may drift, but their roots remain. Volcanoes may collapse, but their magma chambers turn to stone. Mountains may crumble, but their minerals appear again in faraway beaches, in coral reefs, in the walls of canyons carved much later. Even when something disappears, the absence itself becomes a record, a missing fossil, a layer gone dark, an element no longer found in its former concentration. These silences are memories too. The earth holds them all, without urgency, without grief, without needing to explain. It simply stores, and we, slowly, carefully, have learned to read, to take a rock, and see in it not just color and weight, but sequence, to slice ice, and hear the breath of an atmosphere from 100,000 years ago, to scan radiation in bones turned to stone, and know when a creature lived and how it died. The planet has always known how to remember. It is we who are learning how to listen. And still there is so much unread. There are mountains with secrets yet unopened, seafloor sediments with signals not yet decoded, crystals in old cratons that have held their isotopes steady for billions of years, waiting not to be discovered, but to be understood, because the memory is there, everywhere, in dust, in magma, in the angle of a fault, in the tilt of a stratum laid down in a world we've never seen. This is the planet's slow memory. It is not held in a single place. It is the place. It is the ground. It is the story of everything that has ever touched the surface or stirred beneath it. And perhaps, one day, we will read it all. Not just the great events, the extinctions, the collisions, the fires, but the quiet things. The first ripple of wind across a bare plain, the day a river changed course, the moment a crystal grew a single layer thicker in the dark. We do not need to rush. The earth is in no hurry. Its library is vast. Its memory is patient. And we, made of its minerals, of its carbon, of its quiet fire, are part of the record too. Our steps, our breath, our voice, all of it settles somewhere. All of it becomes sediment. All of it, one day, will be remembered. And yet, if this is the memory we now understand, how much deeper might the earth still dream beyond our reach, beyond even time?